Hello students, this is second video of assignment 10.9, last theory assignment of this chapter. In the last video, we saw how to achieve polarization by refraction method. In this video, we'll see that polarization or polarized light can also be produced by reflection of light, and we'll also discuss Brewster's law, which talks about this phenomena, polarization by reflection. So let us start. In 19th century, Maloo observed that when we allow any unpolarized beam of light to fall on surface of any transparent medium, we all know that reflection and refraction both take place. But his observation was slightly more than that. He saw that the light which is reflected is having electric field vectors oscillating in particular plane only. So if we consider this as refracted light, let it be R, and this as reflected light, then he saw that electric field vectors are oscillating in this particular plane in the reflected light. It means that this light is partially plane polarized light. So the electric field vectors which are oscillating in this manner, what these dots are suggesting? Dots are suggesting that electric field vectors are oscillating in plane perpendicular to the screen, are present in the reflected light, whereas here both components are present. These are called sigma components and these are called pi components. So what are pi components? Pi components are the electric field vectors which are uh, in this plane of incidence, whereas sigma components are components of electric field which we cannot draw on this plane because they are perpendicular to this plane. One more observation was that if you change this angle of incidence for some particular value of angle of incidence, this light was found to be totally polarized light, and that angle was given name angle of polarization. So theta p is angle of polarization. You can also say it is polarization angle. Later, Brewster could derive some relation between the refractive index of the transparent medium and polarization angle. Experimentally, it can be shown that these two are at 90 degree. So if I draw it separately, here is the reflected light. We assume that the angle is polarization angle, refracted beam. So this is R and this has to be 90. So I should be able to say that theta p plus 90 degree plus angle of refraction is 180, or else simply theta p plus r has to be 90 degree, right? Let it be result 1. So now if I apply Snell's law, let us consider that medium here is having refractive index eta 1, medium here is having refractive index eta 2. So can I say, according to Snell's law, eta 1 sine theta 1 is equal to eta 2 sine theta 2, right? And then considering the outer medium eta 1 to be 1, and theta 1, we want polarization, so I consider theta p. So sine theta p is equal to eta. Instead of eta 2, let us consider the refractive index to be eta is equal to sine r, because the second angle is r in our case. Okay, let it be result 2. So using 1 can I say that sine theta p is eta sine 90 minus theta p, isn't it? That is cos theta p. And then sine theta p is equal to eta cos theta p. It means that eta is equal to sine theta p upon cos theta p, or eta is tan theta p. This equation is known as Brewster's law, which says that if you know refractive index of any transparent medium, you can determine that at which angle of incidence the reflected light from the surface of this medium will be polarized light. Theta p is angle of polarization, and tangent of theta p is equal to refractive index of the given medium. So that is all about polarization by reflection. Thank you.